Welcome to this new episode of the Dinosaur Stories podcast. Today, I want you to picture a really specific, very famous movie scene.
Oh, I think I know exactly the one you're talking about.
Right. So it's pouring rain. It's the middle of the night in this lush tropical jungle. And you're watching this bumbling computer programmer trying to winch his Jeep out of the thick mud.
He drops his fake can of shaving cream into a puddle, right?
Exactly, yeah. And then he hears this soft, almost hooting sound. He turns around and he comes face to face with this tiny, cute, dog-sized dinosaur.
It tilts its head, coos at him, and then, well, the nightmare begins.
Yeah, a massive neck frill suddenly expands. You hear that terrifying, rattling startup, and it spits this blinding black venom right into his eyes.
Honestly, it remains one of the most effective jump scares in cinematic history. I mean, for anyone who grew up watching it, that image is just permanently burned into our cultural consciousness.
It really is. But, and here's the massive paradigm shift we are bringing you today in our deep dive into the source material, almost everything Hollywood taught you about that animal, the Dilophosaurus, is entirely fabricated. It is a complete myth.
Completely made up, yeah.
The real creature was not the size of a golden retriever. It was the size of a fully grown brown bear. It was the apex predator of its era, and it absolutely did not need to spit venom to take you down.
Yeah, I mean, for about 80 years, the Dilophosaurus was basically considered by paleontologists to be the best, worst-known dinosaur.
The best, worst, no.
Right, because we had the name, and we certainly had the fossils, but our understanding of its true anatomy, like its daily life, was completely shrouded. It was obscured by this fog of mid-century plaster reconstructions and, decades of pop culture fiction.
Wow.
It actually wasn't until a massive, comprehensive redescription of the fossils in 2020 that we finally uncovered the truth about the first large meat-eating dinosaur of North America.
And that is our mission for today's deep dive. We are going to strip away the movie magic. We are going to tear down the Hollywood chimera to uncover the true scientific, historical, and cultural facts about the Dilophosaurus.
Right, because to really understand the real animal, we first have to deconstruct the myth we all know so well.
Okay, let's unpack this. If we look at that iconic movie monster, it essentially has three defining traits, right? The venom, the expanding neck frill, and its tiny dog-like size.
Yeah.
But none of that is in the rocks. So where did the venom actually come from?
Well, the venom was invented entirely out of thin air by Michael Crichton, the author of the original novel. He needed a specific narrative device.
Oh, really? Just for the story?
Yeah, exactly. Crichton wanted to show the audience that recreating ancient DNA is inherently unpredictable. The scientists in his story hubristically believed they had total control over their theme park. So by giving the Dilophosaurus this deadly trait that the geneticists couldn't possibly have anticipated, Crichton basically proved that nature cannot be contained.
That's brilliant for a novel, but it's totally fiction. What about the frill, though? That feels almost biological, like a real Australian frilled lizard.
It does.
I imagine the film's director and the design team just sort of grafted that real-world defense mechanism onto the dinosaur for a visual scare.
That is precisely the case. They wanted a striking visual flair to show the animal transitioning from seemingly harmless to highly aggressive in a split second.
And what about the size?
Well, they intentionally shrank the Dilophosaurus down to about 4 feet tall because they didn't want audiences confusing it with the velociraptors.
Right, because the raptors were the main antagonists of the film.
Exactly. And interestingly enough, the movie's rather boxy, stout skull design wasn't even based on a Dilophosaurus.
Wait, really? What was it based on?
They modeled it after a completely different Chinese dinosaur called Sinosaurus, mainly because the real Dilophosaurus skull was perhaps a bit too slender for their monster design.
That is wild. So the filmmakers essentially grafted an Australian reptile onto a Chinese dinosaur, shrunk it, and called it a Dilophosaurus.
It's the ultimate cinematic chimera, yeah.
That makes complete sense from a Hollywood perspective. But as a listener, you might be wondering about the physical evidence. I mean, I understand the size discrepancy because we literally have the bones to measure.
Right.
But what about the soft tissue? If you're a paleontologist staring at a 190-million-year-old rock, how can you definitively rule out a venom gland or a fleshy neck frill? Couldn't that stuff just rot away without leaving a trace?
It's a great question because, soft tissue absolutely does rot. However, soft tissues of that magnitude leave permanent architectural evidence on the skeleton itself. We call these skeletal correlates.
Skeletal correlates.
Yeah, so to support a large, expanding neck frill, an animal requires specific skeletal modifications like elongated neck ribs or highly visible muscle attachment scars on the neck bones.
Oh, I see. So to flare a massive frill, you need
Yeah.
massive muscles, and those muscles have to anchor to the bones somehow.
Exactly that. And the neck bones of the Dilophosaurus are completely smooth in that regard. There are no anchors for frill muscles at all.
And I'm guessing the venom is the same story.
Yep. Venom delivery systems require similar skeletal correlates, like think of a modern spitting cobra. They have highly specialized dental channels, grooves, and hollowed-out fangs to direct the venom.
And the Dilophosaurus didn't have those?
Not at all. The teeth have been scanned and studied extensively. There are no grooves, no channels, no hollow fangs. It was simply a movie monster.
Wow. So how did a 23-foot-long, 900-pound apex predator become so misunderstood by science in the first place? Looking at the sources, it all traces back to a really messy history of discovery.
Yeah, it was a decades-long case of mistaken identity, mostly driven by the limitations of early paleontology.
The origin story is actually captivating, though. In 1940, a Navajo man named Jesse Williams was navigating the really striking purplish badlands of the Kayenta Formation in northern Arizona, and he discovered these massive bones weathering right out of the shale. Then, in 1942, a team from the University of California excavated them.
Right, and culturally, that area has an incredibly rich history long before Western paleontologists ever arrived.
Definitely. The ancestral Pueblones and the Navajo had lived alongside these fossil beds for centuries. Navajo myths actually interpreted the dinosaur fossils and tracks as the remains of slain monsters.
Which makes perfect sense when you see them.
Right. And ancestral Pueblones even carved petroglyphs near the trackways. They were practicing their own early form of paleontology, trying to logically explain these giant footprints in the stone.
Which brings up a fascinating parallel about how modern science also struggles to categorize the unknown. When paleontologist Samuel Wells brought those first skulls back from Arizona in the 1940s, they were badly crushed by geologic pressure.
So they couldn't tell what it was.
Right. He couldn't fully identify the animal's unique features, so he initially named it Megalosaurus weatherilli, because at the time, Megalosaurus was what we call a wastebasket taxon.
A wastebasket taxon. I love that. That is such a brilliantly descriptive term.
It really is. It literally functioned as a scientific dumping ground. Back then, if paleontologists found a generic, large, meat-eating dinosaur and didn't know exactly what it was, they just tossed it into the Megalosaurus genus.
Just a placeholder for their own uncertainty.
Exactly.
But then comes this incredible moment in 1964. Wells returns to the same area in Arizona, and he stumbles upon a larger, more complete skeleton. And this one has an intact skull.
With a very big surprise on top.
Yes. He realizes there are two massive, incredibly thin bone crests running along the top of its head. I read that Wells famously said finding those crests was as shocking as finding wings on a worm.
Yeah, it completely upended what they thought they knew.
So because of this bizarre feature, in 1970, he officially renamed the animal Dilophosaurus, which translates to two-crested lizard.
Yet, even with the new name and the crests, the confusion persisted for another 50 years. And this is due to a practice we refer to as the plaster problem.
Plaster problem.
Yeah, those early reconstructions in the 40s and 50s relied heavily on plaster of Paris to fill in the missing gaps of the crushed bones. They wanted them to look impressive in museum displays. But over the decades, that plaster hardened, stained, and blended in.
Oh no. So you couldn't tell what was real bone.
Exactly. It became increasingly difficult for scientists to tell where the actual fossil ended and the sculptor's plaster began.
So scientists were essentially studying artistic interpretations, thinking they were analyzing a 190-million-year-old bone.
They really were, and that is why the 2020 redescription by paleontologists Adam Marsh and Timothy Rowe was so revolutionary.
Right, because they finally cleared all that up.
Yeah, they went back to the original fossils and used modern scanning technology to digitally and physically strip away 80 years of artifice. They finally revealed the true anatomy of the animal beneath.
And with that accurate 2020 skeleton finally assembled, scientists realized that Dilophosaurus was not some weak, fragile scavenger. It was a highly advanced killing machine.
It really was. For a very long time, the scientific community had perpetuated this weak jaw myth, which the new research completely dismantled.
Right, because if you look at the skulls from earlier reconstructions, there is this bizarre anatomical feature called a subnarial gap. or diastema.
Essentially a visible kink in the upper jaw.
Exactly, right below the nostril. For decades, scientists looked at that notch and assumed it was a structural weak point. They theorized the jaw would just snap if it struggled with large prey, so it must have spent its life scavenging dead carcasses or, eating fish.
Yeah, catching slippery little fish.
But if you think about it logically, that doesn't add up.
Hmm.
If you are a 23-foot-long, 900-pound giant, literally the biggest land predator in North America at the time, how does it survive with a supposedly fragile, snaggle-toothed jaw? A top-tier predator needs the biological hardware to actively take down large prey.
What's fascinating here is that the 2020 biomechanical findings completely validate your skepticism.
Oh, really?
Yeah. When Marsh and Rowe analyzed the actual jaw bones without the misleading plaster, they found massive muscle anchors. The jaw was actually incredibly robust.
And the teeth?
The teeth were not the conical, needle-like teeth you see in strict fish eaters. They were long, flat, and deeply serrated like steak knives, perfectly evolved for slicing through flesh.
And we even have the forensic proof to back that up, right?
Hmm.
Paleontologists found the remains of a large plant-eating dinosaur called Scarier in the same region, and his bones are covered in deep puncture marks.
Matching the exact spacing and shape of Dilophosaurus teeth.
Wow. So it was actively hunting the largest prey available.
Oh, definitely. But the diet is only half the story. The 2020 research also revealed a profound detail about its skeleton. The bones of the skull and the neck were filled with honeycomb-like air pockets.
Literally like biological bubble wrap built right into the skeleton. That's incredible.
The implication of those air sacs is massive. First, they significantly lightened the 900-pound animal, making it much less cumbersome. But more importantly, it indicates that Dilophosaurus possessed a unidirectional respiratory system, much like modern birds.
Okay, for you listening, let's break down unidirectional breathing because it is an absolute biological superpower. As mammals, we breathe like a bellows. We pull air in, absorb the oxygen, and push the stale air back out the same way.
Right, it's a cul-de-sac.
Exactly. The fresh air mixes with the stale air. But unidirectional breathing in birds and dinosaurs is a one-way street.
Yeah, the air sacs act like continuous biological pumps. When the animal inhales, fresh air goes into posterior sacs, gets pushed across the lungs, then into anterior sacs, and finally out.
So air is flowing in a continuous loop across the lungs. They are constantly bathed in fresh oxygen, whether inhaling or exhaling. That is essentially a biological supercharger.
It is, and that supercharger fuels a massive metabolism. This wasn't a sluggish, cold-blooded reptile. This was a highly active, agile hunter capable of reaching bursts of speed up to 28 miles per hour.
28 miles per hour? If you picture a grizzly bear-sized predator running at you with the speed of an emu, without ever getting winded, that completely rewrites how we view these animals.
It was an absolute terror of its environment.
But here's where it gets really interesting. If this animal is such a fast, powerful killer, why on earth does it have those two delicate, paper-thin bone crests on the top of its head?
Right, it seems counterintuitive.
If it's slamming into a struggling Ceratosaurus at high speeds, wouldn't those fragile crests just snap right off?
They absolutely would shatter in a fight, which tells us definitively that they were not used for combat or headbutting. The crests were incredibly delicate.
So what purpose do they serve if they're a physical liability?
Visual and social display. If we continue with the avian connection, those thin, bony cores we see in the fossils were very likely covered in a thick sheath of keratin.
Keratin, like what our fingernails or a bird's beak is made of.
Exactly, which means in life, the crests could have been significantly larger than the bone suggests, and potentially brightly colored. And because those air sacs extended all the way up into the crests, scientists hypothesized they might have been connected to inflatable throat pouches.
Wait, like a modern frigate bird? The ones that puff out that giant bright red balloon on their chest to attract a mate?
That is a perfect comparison. Or like the brightly colored casque on a cassowary. These visual and vocal displays would have been crucial for species recognition or attracting mates.
If this animal is sporting bright crests and breathing through avian air sacs, it forces us to ask about its appearance. There's a lively debate from the Reddit sources. Did it have feathers? Because a giant crested, fluffy apex predator is just mind-blowing.
It really is, and it's a huge debate. To be clear, we don't have a direct fossilized feather attached to a Dilophosaurus. However, there's a famous trace fossil from Massachusetts that heavily implies it.
The resting trace fossil, right?
Yeah, essentially a dinosaur's body imprint in the mud. A theropod of the exact size and age of a Dilophosaurus sat down to rest. And surrounding the impression of its belly are trace marks that look remarkably like the fine imprints of soft down or belly feathers.
That is amazing, like a 190-million-year-old snapshot of a dinosaur taking a nap. But there is some nuance to this debate, right?
Yes. Some scientists argue those specific marks are just sedimentological artifacts, basically mud drag marks from the animal shifting its weight.
Ah, so maybe not feathers.
Right, but even so, the broader discovery of protofeathers in ancestral dinosaurs makes a fuzzy Dilophosaurus highly plausible.
Wow. So beyond what they looked like, the trace fossils and bones give us a hauntingly detailed snapshot of exactly how these animals lived and suffered.
Life in the early Jurassic was incredibly unforgiving.
It really was. There's another remarkable trackway in Utah, SGDS 18.T1. It reads like a detective story frozen in stone. You can trace the exact movements of a Dilophosaurus as it shuffled down a beach, crouched on its heels, and rested its hands on the ground.
And that single moment was groundbreaking for paleontology because it definitively debunked the zombie hands.
Zombie hands.
Yeah. For decades, movies always showed predatory dinosaurs with their wrists pronated, meaning the palms faced downward toward the ground.
Like they're playing a piano.
Exactly. But the Utah trace fossil proves their palms actually faced medially inward, toward each other, like a bird about to clap. Their anatomy physically prevented them from twisting their wrists downward.
It's incredible what a simple set of footprints can tell us. And we look at paleopathology, the study of ancient diseases. We learn that the original Dilophosaurus lived an unbelievably savage life.
You're referring to the holotype specimen, yeah.
Right. For you listening, the holotype is the very first primary specimen used to define the species. And this specific Dilophosaurus had a staggering 8 afflicted bones.
The sheer volume of trauma is difficult to comprehend.
A fractured shoulder blade, a fractured arm, bone tumors, abscesses, and a permanently deformed, twisted finger likely caused by osteodysplasia.
Which is a severely painful condition that causes abnormal bone growth. I want you to pause and imagine the resilience required here. This animal suffered catastrophic injuries, maybe from crashing into a rock or fighting a rival, yet the bones show extensive healing.
Meaning it survived for months or years without the full use of its arms.
Exactly. It was forced to adapt its hunting strategies, relying solely on its jaws and feet. It's a profound testament to its hardiness.
So what does this all mean? When we put all these pieces together, the Dilophosaurus wasn't a cute, venom-spitting movie prop. It was a resilient 23-foot, bird-like apex predator with a bone-crushing bite, dazzling display crests, and a life of brutal survival.
And for you listening, I think learning about the real Dilophosaurus teaches us to question the media we consume. Science is an ongoing process of correcting our past mistakes, from wastebasket classifications to Hollywood chimeras, to find a reality that is far more breathtaking.
It really is. And it leaves me with this final thought for you to mull over. If Hollywood had to invent a frill and venom just to make this dinosaur seem scary, what does it say about us that the actual truth, a giant, brightly crested, deeply scarred, agile predator with a bird-like respiratory system, is so much more terrifying and wonderful? What other pop culture monsters are hiding a far more incredible fossil reality waiting for you to uncover?